All right, here we go. Happy day 1.6 video. What I want you to do, I want you to think about this, explore. I'll get you started here. Yada, yada, yada. Each proton has a positive charge, and electrons have a negative charge. All right, this is our explore for today. And atom can gain or lose electrons. Just read that. I'm not going to read it to you. It's not story time. Okay. Hopefully you read that by now. All right. So let's talk about the charge from our protons. So if I have 11 protons, all right, that means I have 11 as my charge. Now it's a positive 11. Okay, it is a positive 11. All right. I'm not going to write plus 11. Okay. My charge for my electrons would be negative 11. Obviously, I have to write the actual negative in there. Okay. If I have a sodium ion, okay, notice how there's this little plus here. All right, there's that little plus there for a reason. Well, my charge for my protons is 11, and my charge for my electrons is negative 10. So there's a positive 1 excess. All right. I have a plus 1. I have one little positive charge. Knowing this, I want you to try and fill out the rest of the table. So go ahead and pause the video now and fill out the rest. All right, so here's what I came up with there. Okay, obviously we're just filling in positive and negative numbers here. If you'll notice down here with aluminum, ion, it's 3 plus because, well, there's a 3 positive charge, like an excess charge of 3. Okay, I'm trying to teach you a little bit of science here. I'm doing my best. Science wasn't necessarily my forte, and all right, when I was your age. Okay, let's talk about this one. An atom can be charged a charged ion only by gaining or losing electrons, not protons. An atom and an ion of the same element always have the same number of protons. Use this information to complete the following chart. So if we look here, okay, if my symbol is this, all right, you'll notice on that previous, number 2, if you're looking at your book, if a net charge of an ion is plus 1 or minus 1, only the positive sign is shown. So if this is just a plus, then that means I have a positive 1 charge. All right, my net charge is plus 1. Okay, so obviously, if my protons are always positive and electrons are negative. Okay, if my net charge is 0, that means these two columns here must add to 0. So this obviously is negative 1. All right. If I have a positive 1 plus 1 charge here, then that means I have to have a 1 here. Okay. If I have a negative 2 charge here, all right, if I have a negative 2 charge here, I can do a lot of different things there. If I know that the oxygen atom is 8, all right, look, there's no positive or negative here. Okay, so number of electrons is going to be 8. I don't know why I put that. You don't need to really put this negative here, actually. All right. Then my number of protons also has to be 8 to get a 0 net charge because there's nothing here. Having said that, if I need negative 2 net charge and the number of protons is always the same, always have the same number of protons, okay, that means I know that this is going to be 20 as well. Well, if I want a negative 2, a net charge of negative 2, then that means this number has to be, if it's going to be considered negative, it has to be 2 more than 8, which is 10. Okay. Again, how do I know that? Well, I know that this is my negative column, this is my positive column. All right, if I do 8 and then I add this number has to be 2 more, okay, to get that negative 2. All right, 8, you want to think of this as 8 minus 10 gives me negative 2. Okay, calcium atom, there's no net charge here. All right, there's no symbol here. So I know this is going to be 0. So that means these must be even. Same idea. Now I'm looking for a 2 plus, right? A positive 2 net charge. So I'm going to write plus 2. So that means the number of electrons has to be 2 less than the number of protons, and 18. All right, so if you just thought to yourself, holy buckets, Mr. Marconi, what the heck? I thought this was math class. You're right, it is math class. But we're trying to show you how negative numbers can be used in other disciplines, okay? Okay, let's look at the next page here. All right, so this is kind of what we're doing for today. These are 2 questions I want you to think about for today. All right, for this section. All right, make sure you read that. Okay. All right, describe the kind of numbers you would use to answer each question. All right, so we want to think about this. Is this going to be, are these going to be like positive numbers? Are they going to be negative numbers? Are they going to be whole numbers? Or are they going to be decimals? All right, so for a number of cars parked in a parking lot, these are going to be whole numbers. Like 0, 1, 2, 3, 4. Okay. Obviously, I can't have a fraction of a car. I can't have a negative of a car either. So I won't have any negatives there. All right. Part B, what is the depth of the submarine relative to sea level if it is descending at a rate of 200 feet per hour? All right. So I want to think about this. Obviously, if we're thinking wow. Okay. Here, all right, these can be fractions, they can be decimals, they can be whole numbers. All right, we can have a fraction of a foot. All right, but the most important part of this question is, are these going to be positive or negative? Well, if a submarine is diving, it's descending, and I'm looking at negative numbers. And I'm going to write up here positive in this one. All right. Beth purchases a candy bar to share with her children and husband. How much will each person get? Okay, so are these going to be positive? If I'm sharing it, yeah, I have a positive number of candy bar. It doesn't like go away. Well, obviously it goes away once you eat it, but I have the candy, right? So how would I describe it? I'm going to use a fraction or decimal to describe these numbers. I guess the positive, you can think of it as a positive or negative number. That's a decimal. I'm sorry if it's hard to read. So I'm going to erase this positive part. If you wrote it down, just scribble it out. It's not a big deal. Because you can think about it as either or. All right. So that doesn't really describe what we're trying to do. Okay. The most important, the biggest descriptor is fraction or decimal. All right. Let's keep going here. Jake uses a spreadsheet to keep track of his finances. He lists all purchases and bills for the month, okay, as well as income. How much money does he have left after paying his bills? All right, so this could also be positive or negative. He could have no money left over after paying his bills. He could have less money left over if he didn't do a great job, budgeting, or if it's just not feasible. All right, so he could have less money, he could have zero money, he could have positive amount of money. All right, the best way to describe this would be, if I'm talking about money, I can think of decimals. All right, I can think of decimals. Historically, sets of numbers, because money comes in decimals, right? Sets of numbers have been invented to help solve problems or satisfy needs. The notation was developed to record their operations. That's sick. All right, so this is just a little bit about negative number. We know what negative numbers are. You've talked about negative numbers. Okay, but let's talk about this. The size of a number, all right, right here, is the informal way of saying how far a number is from zero on a number line. In mathematics, we refer to the size of a number as its absolute value. Okay, that is something you've seen before. Absolute. If I ask you to take the absolute value of -4, that would just be 4. If I ask you to take the absolute value of +4, that would be 4. Because the absolute value, remember, measures our distance from zero. All right, that's what we are doing. Okay, it's 4 units away from zero, and it's always going to be positive. I don't like saying always, but it will always be positive. Okay, so here's what I want you to do. Try these for a second here. What is the opposite of 8? Try to answer question number 5. All right, pause the video for a minute. If you can't, that's all right, but do your best. All right, so I'm going to keep going here. What is the opposite of 8? Well, hopefully you came up with positive 8, or so the opposite of -8. You should have gotten positive 8. Find the absolute value of -11. That should just be 11. All right, it's always going to be positive. It's a distance from zero. What is the sign of 24? It's positive. and the size is 24. Size is 24, or the distance from 0, or the absolute value is 24. Read and simplify. So what does this say? Well, this says anytime I see like a negative like this, I like to think of it as the opposite. All right, so I would consider this the opposite of -6. And then if I want to simplify it, that's just 6. Okay. Sometimes a lot of us, when we see this, all right, we may just think about, oh, I have two negatives. That's just one big positive. Okay. And that's fine. But you're not, that is correct. You're right. Read and simplify. The opposite, I'm going to write oppo of the absolute value of -6, which is just -6. Okay, so if the absolute value of 6 or -6 is 6, then I take the opposite of that, so I get -6. All right. The following examples do not use negative numbers, but each has a positive or negative meaning. Determine the meaning. Determine whether the meaning is positive or negative. Okay. If it is negative, write it using a negative number. So 100 feet below sea level. Well, we talked about this in an earlier example about being below sea level. So this has to be negative, and I would write that as -400. Yeah. I guess you could say feet or whatever, but I'm gonna write -100. All right. Next one, 500 in the black. Well, if you're in the red, that means that's not good. You are losing money. So if you're in the black, that's technically positive. All right. The following situations contain negative numbers in real life situations. Interpret what each one's mean, or what each one means. This would be, what is this? 30 degrees Fahrenheit. Was that below 0? Yeah, below 0. All right, I'm going to read what the book says for part B, and I don't really like this. It says for polar results, a range of likely values is found by taking the percent in the poll and adding or subtracting the margin of error. So that's our margin of error, all right, in poll results. Okay. Yeah. I would have never asked you a question like this. The book has it. I just added it there because I liked part A. All right. That concludes our video for today. Okay. Hop back into class. Yeah.